So this is for question 8 and 10 on page 541. So question 8 asks you to find the point Q that is closest to point P that's on the line that's given. Okay, so the equation of the line is here. Put that in parametric form and we get the coordinates of any point Q on that line. We know that the vector PQ is perpendicular to the line, so it's perpendicular to the direction vector of the line. So that means that PQ dot M equals 0. Their dot product is 0. So PQ equals OQ minus OP. We can work out the coordinates of that right here. PQ dot M equals 0. So if we keep working that out, we get a single equation with one unknown. Solve for S, which is going to be 6 over 11, and sub that into point Q, the point Q that we made up here. Sub that in there, and we get the coordinates of that point. Okay, so number 10, I'm just going to lay it out. I'm not actually going to solve it here. So number 10 wants a point that is on the that's reflected in the line, this line here. So a point that's reflected from that one in that line, so you're going to get this A prime point here. If you look at it in terms of vectors, the vector AQ is going to equal QA prime. Point Q is going to have these coordinates based on the equation of that line. Those are the parametric equations. Vector AQ is this one. Okay? And so we need to find point Q. The way we find point Q is the same way as we did in question 8. So AQ is perpendicular to M, so AQ dot M equals 0. From that you figure out what point Q is. And then once you've got point Q, you can use this formula basically here to find OA primed, and that will give you A primed. And A primed should be this value here. Okay. Another question is page 549, number 3, A and B. So for 3A, not so hard, distance from a point to a plane, so two parallel planes. Pick a point on one of them, so plane 2, and find the distance to the other one. It's 5 units. Then they want you to find 2 points. Sorry, they want you to find a plane that is right in the middle of these two. Okay, so in order to do that, you're going to find a midpoint between these two planes and use the same normal. Pick any 2 points on the planes, and the midpoint is right in the middle. Using congruent triangles, that midpoint between any 2 points will be right in the middle. Use the normal that you've got, and you will sub that point in, and you can get the equation of that plane.